I'm Ernie Wright. I work in the Scientific Visualization Studio at NASA's Goddard Space Flight Center. We're looking at a computer model of the view at the south pole of the moon. This is like a time lapse to show the motion of the sun and the Earth and how the shadows change over time. Things don't rise and set in the usual way here. The sun travels around the horizon, never getting more than 1.5 degrees above or below it, so there are always these long shadows. And from here, the Earth appears to be upside down and rotating backwards, but that's just because of our point of view. The Earth doesn't move much in the moon's sky. It's always in roughly the same place, just sort of bobbing around. That's true everywhere on the near side of the moon. It's a consequence of the moon always pointing the same face toward Earth. It takes about a month for the sun to make a complete circuit around the horizon, and every so often, it'll pass behind the Earth, creating an eclipse. I've slowed down time here a little so that it's easier to see. On Earth, that would be a total lunar eclipse, the moon passing through the shadow cast by the Earth. But if you're standing on the moon, it's an eclipse of the sun. The terrain at the South Pole is especially rugged. The rim of Shackleton Crater is in the foreground here, and the mountain off on the horizon, unofficially known as Mons Malapert, it's about 85 miles away. Shackleton Crater is about 13 miles wide. Not quite as wide as the Grand Canyon, but it's twice as deep. Sunlight never reaches the crater floor, so temperatures there are around 300 degrees below 0 Fahrenheit. This model of the terrain is made possible by Lunar Reconnaissance Orbiter, which has been mapping the surface of the moon from lunar orbit since 2009. LRO's maps will be incredibly important for exploring the moon and locating water and other resources there.